Here's the answer key for the second fundamental theorem of calculus assignment. This assignment overall is fairly quick to accomplish. Again, we've learned that if we are deriving the antiderivative, they are inverse operations, they are wiping each other out. Ultimately what happens is the variable in the upper bound subs in for the variable in the integrand. So for number 1, we were replacing t with x. So we have x squared minus the square root of x. For number 2, same thing, just an x up here. So we have 1 over x squared plus 4. For number 3, doesn't matter that it's a u here as opposed to a t. Same idea, replace u with dx. So we have the square root of x squared minus 1. Regarding number 4, we have an issue in that x is at the lower bound instead of the upper bound. So we need to rewrite it. So we have the derivative. We're going to swap our bounds, 0 and x. The cost is that we must negate the integral. We then have square root 3s plus 1 ds. And now we treat it like the previous 3 problems. The negative sign is still there. Otherwise, we are replacing s with x. So the opposite of the square root of 3x plus 1. For numbers 5 through 8, we now have more than just x. We have x squared in the case for number 5. We're still going to replace t with x squared. So we're looking at x squared plus 1. However, because we are deriving and the inner function is x squared, we are also going to be required to use the chain rule. This is the ugly, we have to multiply by the derivative of the ugly part. So we're going to multiply this by the derivative of x squared, which is 2x. This answer is fine. If we were to simplify it, we can move the 2x out front. X squared squared is x to the 4th plus 1. With number 6, we're going to do something very similar. We're going to put 2x plus 1 in for t. So we have the sign of the quantity 2x plus 1. But again, our upper bound, our inner function, is something more than just x. So we need to multiply this by its derivative, which is 2. Keep in mind that the 2 belongs to the whole thing, not just 2x plus 1. So another way to write this would be twice the sign of 2x plus 1. With number 7, our x function, inner function, is in the lower bound. We'd like it in the upper bound. So this is equal to the derivative. And we're going to do the same thing that we did with problem number 4. We're going to swap our bounds. We have to negate the integral. So it's the opposite of the integral from 2 to 4x squared of 1 over 1 plus t cubed dt. We can now put 4x squared in for t. So we have the opposite of 1 over 1 plus, and then in parentheses, 4x squared being cubed. Just extend my fraction bar out. And we need to multiply this by the derivative of 4x squared, which is 8x. This is a correct answer. If we were to simplify it slightly, we have our negative and our 8x, which can move up into the numerator. And down below, 1 plus 4 cubed is 64. X squared cubed is x to the 6th. Again, both of these answers are fine. This is the type of answer you would see as one of your options in a multiple choice question on the AP exam. Finally, number 8, we have the square root of x as our upper bound. So we can toss that in. We have the tangent of the square root of x. We need to multiply this by the derivative of the square root of x. So square root of x is the same thing as x to the 1/2. When we derive x to the 1/2, we have 1/2 x to the negative 1/2. This answer is fine. Were we to need to simplify it, We have a fraction, 1 over 2. I'm going to ignore the 1 for a second. Right, so we have 2, and then x to the negative 1/2 becomes x to the positive 1/2, or square root of x, down in the denominator. Up top we have the 1. We also have the tangent of the square root of x. 1 times anything is itself. So 1 times the tangent of the square root of x is the tangent of the square root of x over 2 times the square root of x. That's also a correct answer.